check whether my voice is audible to all or any disturbance.
Yes, sir. Audible for me. Anybody from the
Okay.
audience?
You may please text.
Yeah, you can text.
Okay.
If it is audible, you can text.
Yes, like that. Yeah.
Yes.
Okay. So no voice breaking or disturbance. Everything is okay. Huh?
Okay, sir.
Everything is perfectly okay. Okay. I'll start. So, this is structural and geotechnical requirement for a project. This is nothing but what are all the basic requirement. Structural and geotechnical requirements are the basic requirement for the project. For the students, anybody is there, please don't mistake me by seeing my degree and memberships. These are all time ran. Okay, I was B second class, and the ME fortunately or unfortunately I got first class, and these are all memberships. I didn't try much because of my experience. I got member in Institute of Engineers and Chartered Engineer, and based on my professional practice, I registered as a professional engineer. Okay, I became an entrepreneur because no one gave job. If I was employed, I might not come as an entrepreneur. I don't take risk in my life. As the life is totally risk, I started my career as an entrepreneur. Okay. So, being an entrepreneur, first qualification is you should not be employed. Okay. If it is you are employed, you check about your salary, your EL, ECL, increment, bonus, all. And very rarely people become entrepreneurs. Okay, that is my introduction about me. And the structural and geotechnical requirement for a project for a civil engineer, he has to do a project. So how to approach a project with the design aspect as well as some construction aspect, I am going to explain now. Okay, what is a structure? Structure is a supporting mechanism. You are sitting on a chair, that is a structure. Your load is received by the chair and transferred to the floor. You are using your table also a structure. You are laying on a cot is a structure. But these are all microstructures. But usually structure means buildings. Anything receiving the load and transferring safely the load to the earth is called a structure. Here, any supporting mechanism has to be designed and considered by the civil engineer or the builder. Why people approach civil engineer or structural engineer is nothing but the word called optimization. Optimization is a word mostly used in business world. That is, every business are running with sales, expenses, inputs and outputs. So what are all the money they are spending on business is viewed as a loss. What are all the money they are getting for a business is a profit. So minimizing the loss and maximizing the profit is called optimization in business. In structural engineering, optimization is nothing but minimum material and maximum strength. You have to get the maximum strength and using minimum materials. That is called optimization in structural engineering. So, if you are an uneconomical designer, you will be out of market within few years. Okay. Your reputation may stand for some years, but if you're continuously your buildings are uneconomical, you will be thrown out from market. So you keep in mind whatever you design, be as economical as possible. May not waste any materials necessarily. At the same time, it must have maximum strength with available material. There are steel and RCC structures. Mostly 90% of construction in India is RCC structures. So let me go about some introduction about RCC structures. Concrete is a best material for tightness and toughness. If Prime Minister goes to any country, nearby country, or any countries, and have some strong agreement with the president of that country, next day morning, the papers of India may write, Prime Minister arrived at a concrete solution. That means people believe concrete makes permanent. Steel is the best material in the world. It is well good in stiffness and ductile. It is more elastic than rubber. It's not easy to practical mind to believe it. But in a rubber band, if you apply a pressure, the pull, it will instantaneously elongate. If you leave it, instantaneously come back. Similarly, the steel is much more elastic than a rubber, but the required force is much higher. There are lot of materials tried to reinforce with cement concrete, but still steel is ruling the world with the concrete. Why? Because steel and the concrete have the same coefficient of thermal expansion. For concrete, 11 into 10 to the power minus 6 mm per degree Celsius. For steel, 12 into 10 to the power minus 6 mm per degree Celsius. You know, in our country, places like Chennai or Delhi, where summer temperature is 40-45 degrees Celsius. We are putting AC inside our rooms. We maintain 20 to 25 degrees Celsius. It will not be air conditioned. Our normal climatic conditions in summer 40-45 degrees Celsius, winter 20 degrees in 50 degrees in December. So 20-25 degree into 10 to the power minus 6 into 11 or 12, that much of elongation contraction in the building with respect to the season and the temperature variation within the building. So if a material uniformly expands and contracts, then no problem. If there is unequal expansion contraction, there is some tax. So that is why steel is still ruling the RCC element as a reinforcing material. Okay. Concrete performance improved by steel. Steel is protected against corrosion by concrete and fire by concrete. If a concrete is purely unreinforced material, it will not take flexure or tension. So steel is a very good material. It will only take compression or tension, but when you do is allowable to withstand in the atmosphere due to moisture and the air, it may get corroded. And you know, WTO attacked by a terrorist is a steel building, so it easily caught fire and get melted. So that is a disaster happened. The same terrorist attacked Pentagon building, it's an RCC building. Yes, there are some damage, but not catastrophic as WTO. In this, they will come to a lesson. Steel is protected by fire, by concrete. So this is called mutual benefit, win-win situation. When steel is used in concrete, concrete performance get improved, and steel is also get protected with minimum steel. In steel sector, you have to use the quantity of steel per area is high, but in RCC, the steel is used, quantity is very less. Let us assume there is a concrete slab. These are all coarse aggregates. These are all fine aggregates and cement. There is no steel. Hope you can see this.
Yes, yes.
Yes.
Little bit above.
I load it. It's a slab. I load it. It bend. Obviously, it bend. There are two important forces in RCC. That is compression and tension. If particles are comes closer, okay, that is called compression. If particles are goes away, that is called tension. So wherever the compression comes, you need not worry about steel requirements. Concrete itself has taken care of the compression. But even a mild tension takes place, okay, concrete will crack. For funny things we say in colleges, girls, please don't mistake me. Concrete is a woman. Don't make her tension. If you make tension, relationship will crack. Steel is a gentleman. It is flexible, it is bendable, it is weldable, it is boltable, but it is corrodable. So steel is protected by concrete. Concrete performance is improved by steel. That is a woman after marriage. So this force transfer mechanism is RCC. If there is no tension, don't worry, concrete will take care of compression. Okay. If there is a minor tension, a surface tension itself comes, at least due to heat and expansion, you need steel. So where is steel tension, where is compression? As I already showed this is a slab. Assume this is a slab. Okay. In this slab, assume there are two supports. My hands are two supports. In this slab, when I bend it, the bottom, will there is a particles goes away or comes closer? Here. It will goes away. When it is goes away, either in life or in concrete, it is tension. When particles are comes closer, people comes closer, it is called compression. So tension will be taken care by steel. Compression taken care by concrete. If the behavior is like this, assume a balcony. Okay. Assume a balcony. There is no support. If people are standing on that, how it behaves? Okay. Bend like this. So in this case, the tension is coming on the top. So your reinforcement is requirement on the top. So where is tension? You mandatorily require steel. Where is compression? You need not have steel, even concrete will take care. These are all the components of a building. Any building, it may be a 100-story or a 1-story. This is the components. We are sitting on the, let us assume we are sitting on the first floor. The roof slab receives the load. Okay, the slab receives the load, the slab transferred to the beam. The beam transferred to the columns. The column transferred to the foundation. The foundation transferred to the soil. So this is the structure below the soil is called substructure. The structure above the soil is called, ground level is called superstructure. The superstructure load come to the substructure. The substructure transferred to the soil or the rock mass. Okay. The soil mass has these imaginary lines. This is not exactly the imaginary lines. It is proven. This is how the force is transferred. What are the load you are applying on the soil mass or the rock mass? This is how the stress is transferred. Okay. The line is called isobar. Each line connects equal stress. Immediately after the foundation, load by area. So stress is nothing but load by area. So the stress is very high. Okay, little bit it is Q is stress, Q equal to P by A. So this is Q. At this line, it is 0.9 Q, that is 90% of the pressure. Here is 0.8 cube. All the people, please, this is the webinar. Please note all your doubts. I finish it. Students, students. So I put all those things because if you touch any lines by knowingly, unknowingly, then there is a chance of disasters. If you touch these lines, the soil particles will move, and the foundation may tilt. So, to know the importance, most of the people know. Even you need not be a civil engineer. Most of the people know. This is the foundation. This is the column. This is the beam. This is the slab. But no one knows what is beneath the foundation. That is geotechnical. That is pressure distribution or stress distribution. Okay. Because of that, what happens next? A load is distributed. The pressure is distributed. So if it is B, 2 times B, here B by 2, here B by 2. People in urban area are fighting for land. This is my land I purchased at the square feet of 4,000 rupees per square feet or 5,000 rupees per square feet. So I consent up to the end. That is an offense. Because if you construct up to the setback and up to the boundary, you are constructing your building, you are enjoying your space, but the load is transferred to the neighbor. That is why the authorities are insisting, give the setback on all sides. That is a minimum setback. If there is a setback given, all your stresses are within your boundary, you are not disturbing others. Similarly, you are saying that this is my property, I am constructing like this. Your neighbor also doing like this, and then if by mistake or any deliberate attempt, if he goes below your foundation, your footing, then these lines may get disturbed. Then there is a chance of collapse of your building. So be aware about this. Your building has the boundary beyond what you will think about the outlines. So depends on that. When the load is applied with this pressure distribution, what happens to the soil mass? When somebody enter into your territory, first persons are our defense persons. They encounter. Okay, they first attack. Where are you coming? So they oppose. There are people, okay, to support our defense personalities. Okay, there are supporting people. In the supporting mass, there are people who want to glide. Why you are going to support this? Our army persons or military persons. Be better to escape. But when the people are ready to escape, there are advisors in their family, kith and friends. See, somebody is intruded into our country. our defense personnel are encountering with their life risk. We have to support, but why you people are gliding. So they are giving pressure. That is called surcharge. Surcharge is nothing but from the ground level to the foundation level, the soil is giving their pressure. So that pressure won't allow these soil particles to move away. When these zones get disturbed, if the pressure are more, then what happens? Anyway, our defense personalities will definitely fight till their death. But these people won't support. They will glide. A simple, pretty people, they glide. What happens? Then our defense people come down. Okay, they go back. Then our enemy go inside. This is just for an example I am saying to understand. That is nothing but when the foundation is resting on the soil mass, this zone is called, okay, zone number 1. This zone is pyramid shape. It will encounter these zones are radial shear zones. These zones, to some extent, they support this zone, and other parts try to escape. Then this passive zone don't allow this mass to escape. This everything is in equilibrium. Then even the building is constructed on the soil mass, there will be some minimum disturbance in the soil mass. Okay, you will enjoy inside your home for years, even century. But anything happens within this soil mass, okay, people may bury or something, or people may excavate pipelines or metro tunnel or something. Then the soil mass get disturbed. When the soil mass get disturbed, the zones get disturbed. Then there is a chance of building settlement. So to know all those things, what to do, what type of soil mass, whether my soil mass is withstand or they escape. Yeah, there is a question, the doubt arises within you. Then you have to understand this. You know about your structure. You may use ultratech cement, Tata steel, whatever may be. So you know about your structure, but you don't know about the soil. For that only a soil test is required. All loads comes to the foundation. Foundation transfer to load to the soil. The structure is an artificial material. Soil is a natural material. Structure is artificial. You can order. I want this type of FCK, compressive strength. I want this type of soil. This type of steel. I want FE 500, 500D, 550, 550D. So you can order the material, structural material, but you cannot order the soil mass to give the bearing capacity. What is available, you have to adapt to yourself. So soil is a natural material. It has its own strength, it has its own bearing capacity. So soil below the depth, up to significant depth, will take care of your load of the structure. Don't assume that if you are constructing a building on the North Pole, it transfers the load to the South Pole. Only up to the significant depth only the soil mass get disturbed. Beneath that, it won't get disturbed. So understand about the property of soil mass below the foundation. It is very important to test the soil. Don't take risk in this. Yes, soil test is little bit costly, but not costly than our medical bills. Okay. When you are going for any illness, okay, immediately your doctors insist to go for blood test. That too in corona period, even you are sneezing or coughing, okay, no doctor will take risk. They insist to go for blood test, including COVID-19 test. Okay, rapid test kit, whatever may be. Here, a soil test is as important as blood test. If a doctor make a mistake, one person die at one moment. If an engineer make a mistake, there is a catastrophe. We cannot count how many is casualties. So my words may be a little bit stronger. But I'm sorry, there is that much importance is there. Do the soil tests properly. Okay. In this, there are companies, I am very sorry to say, there are companies, sir, I want soil test to be done or soil report you want. Because the approval authorities are insisting for soil test. So automatically some crooked mind comes in people's or some bad contractors' mind. They want soil report. Soil report is nothing but a manage or manipulate old reports taken in that area. Control C, Control V. That's all. They simply change the street name and plot number and survey number and give it. The nearby site is my adjacent site. Don't do this, because myself, my brother, or siblings for the same parent, but my blood report is different. My brother's blood report is different. So for treatment for me is different. Treatment for my brothers may be different. Similarly, a particular site has to be tested. What is beneath your foundation? For 4,000 rupees worth Mixi, they are giving a card, guarantee card. There is even on iron box they are giving a guarantee card. For mobile phone there is a 1-year guarantee card. For your site is worth 50 lakhs, even 5 crores. So whoever is giving a guarantee card, soil report is a guarantee card. See, in this, there are a lot of tests to perform on the soil mass. In this, one test is called standard penetration test. This very famous test. Even though there are a lot of tests available, static cone penetration test, dynamic cone penetration test, plate load test, field vane shear test, pressure meter test, there are a lot of tests, but standard penetration test, the word standard, it's all over the world standardized. Other tests also standardized, but this is standardized in all over the world in a same manner. It's a little bit cumbersome test also, but that is why people don't want to make any innovations. In this, there is the basic is that it's 63.5 kg, almost 65 kg hammer to drop for 75 centimeter fall. 15 centimeter is a seating drive. When the hammer, next slide may show you what is the standard penetration test. There is a 63.5 kg hammer, 750 mm, 760 mm drop. There is a pulley arrangement by rope or chain. They pull and then drop it by gravitational and hit the anvil, the supporting system. Then there is a drilling rod, it goes inside the soil mass. First 15 centimeter they leave it. For next 30 centimeter penetration or 30 centimeter penetration, how many blows required? It's a common sense. For 30 centimeter penetration, it goes by one beat or 2 beat. Soil is loose or soft. If there is a 30 beat or 40 beat, the soil will not go even strongly. That means soil is very strong. So, in this, the standard penetration test gives about the field condition of the soil mass. So how to choose the foundation based on the standard penetration test? If you are going, most of the people have an idea about shallow foundation, that is isolated or foundation or raft foundation, normal conventional foundation. What type of soil you are going for a normal conventional shallow foundation? The N value, that is N value is nothing but number of blows. For 30 centimeter penetration, how many blows required? Okay, that is number of blows. The number of blows should be minimum of 10. If it is not 10, then it is not possible to rest the foundation on the soil. The value 10, N value, number of blows is 10 means 10 blows required for 30 centimeter penetration. That means approximately it is 10 tons per square meter the soil can withstand. If the N value is less than 10, then you can go for a deeper depth. And then say the top 1 meter N value is 7 or 6. Another 2 meter N value is 15 or 16. Then you got to put the foundation on the N values where is 15 or 16. If for 3 meter N value is 25, it is better to go for 3 meter. But be sure, go back to the previous slides. Okay. Don't go below your neighbors or any existing foundations. Okay, your N value here may be 15, here may be 25. People may excavate up to here because they are curious about okay, N value is good. But if you are going below that, there is chance of okay, soil movement. Okay, so how to choose the foundation is don't go below 3 meters because normal Indian human height is 1.6 to 1.65 meters. If anything happens, if you raise the hand not more than 2 meters, so inside the pit, you have to rescue the people. So it is not advisable to go beyond 2 meters at least, but the maximum 3 meters. If the N value may be 40 or 3.5 meters, don't go to 3.5 unless without proper armor or any proper protection or storing system. Okay, so shallow foundation has lesser settlement. If you are applying a force on the soil mass, definitely the soil mass sink and it will settle. If the N values are more than 15, the settlement will be very less. Okay. As per, there is a code called 1893, that is seismic code. India has 5 earthquake zones. In this, where N values are more than 15 in zone 3, like Chennai, Coimbatore, and some parts of Kerala, where zone 3. In this zone 3, it is better to go for more than 15. If it is in zone 2, you can go up to 10 is flexible in the code. So whatever we could do, civil engineers do as per code. Even tomorrow anything happens, the investigation agencies like court or IIT or any forensic experts go through your documents. If you go everything as per code, you are safe. The structure should be safe, and the paper also, all your activities should be registered as per code, as per IS 456, as per IS 875, like that. How the police personnel and how the lawyers are using IPC. Same the way civil engineers has to be follow IS codes. And the choice of foundation we come across and how to give the size of foundation. If the bearing capacity is can be renamed as safe bearing capacity. What is safe bearing capacity? I am 95 kg weight person. If Ashok Kumar gives a suitcase of 10 kg gold, hope Ashok Kumar gives me 10 kg gold in a suitcase, I am very happily take. Thank you, Ashok Kumar, 10 kg gold in one suitcase. I can smartly walk. If Ashok Kumar gives 20 kg suitcase in a suitcase, again I take because 20 kg of gold, but I bend and then I have to carry the suitcase. If Ashok Kumar gives 40 kg or 50 kg gold, sir, anyway, please take it, sir. I have to accept it, but I bend like a coolie. Yeah. I have to hold that suitcase. That means I totally deformed based on the load. Similarly, every soil has bearing capacity. It will bear. It will not totally collapse. For the minimum settlement described in the code, what type of foundation, what type of soil, this is the allowable settlement. It is prescribed in National Building Code as well as 11880099. The code it gives for that particular type of soil, the particular type of foundation, this much should be the settlement. Otherwise, the building will crack. So, for particular settlement, how much is the bearing capacity? That is called safe bearing capacity. Usually, the ultimate bearing capacity, the maximum bearing capacity divided by factor of safety, gives the safe bearing capacity. The safe bearing capacity increases, the size of foundation decreases economically. The safe bearing capacity is less than the size of foundation, the area of foundation requirement is more uneconomical. Okay. With this, I make a small break. I come back in a minute. Ashok, is it okay?
Yeah, fine, sir. Fine.
1 minute.
Meanwhile, you can type your queries up to whatever sir has covered. You can type your queries in the chat box. He will come and answer. This is opportunity because he is a very known person and he is a practical person, and as per the codes only he does the design. So there is a good demand for his work also. So you can write your queries in the chat box so that the time we can save at the end.
He is making phone calls. That is why I come to know who are there. Okay, I'll handle them later. So far we come around. What about the geotechnical requirements? Now we go into the structural requirement. Any doubts about geotechnical requirements? We'll discuss, and then otherwise we'll go into.
No, 3-4 questions.
Yes. We can explain. I can explain.
Yeah.
Yes.
They posted in the message box. Can I read
1 minute.
it? Can I read it?
Yeah, please.
Yeah, give me a second.
Okay.
What is the range of soil or lateral soil found in South India, particularly in Kerala? This is asked by
Kerala is laterite soil mostly. Some places marine clay also there in Cochin around. But as a civil engineer, you should approach how a doctor approach every patient. Okay, all over the world, people have A, B, O, positive, negative, AB negative, AB positive, A1 negative blood groups, some rare Bombay blood group. Okay, but these are all information known to everyone. Okay, so don't generalize. Try to, again and again, I am insisting. Okay, don't generalize. If you are going to do a project at a particular site, you have to test the soil at a particular site. How a patient is treating for his own blood report. How much is the RBC? How much is his
WBC.
blood sugar level, everything. So in Kerala, laterite soil is on the northern sides, and mostly southern sides you have marine clay and the soft clay contents. At the deeper depth, they have strong soil. In Kannur area and all, you have some strong strata, laterite and all. So these are all some just geological informations. How South Indians have genes. Okay. How North Indian have some genes like that. Similarly, so it is not your person to person vary the weakness and all. Similarly, when you are going to do the project, be serious about a particular site. Okay.
And the other question is active and passive pressure that affect on a foundation. Sir, tell about
Yes.
active and passive pressure that affects for the foundation.
See, when load is applied on the foundation, the first zone is affected here. Okay. So there is an action, there is an opposite reaction. But as the pressure affected is more, this try to come down. Okay, this is acting in active manner. When this is acting in active manner, the charge that is from the ground surface to the foundation, your foundations are flanked by the soil mass. Okay, this soil mass is anyway acting in the, this is also acting, but this is acting passive to the movement. These are active conditions, these are all passive to the movement of soil mass. So in this, if you are anyway disturbing for any development like some sewage treatment plants or pipelines, be careful. Okay? There are some calculations, so you have to be very careful. If you are affecting the passive zones, then there is no resistance for the active zone. Then there is definitely chance of the building make accidents.
Other question is how we will get to know whether the pressure bulb of the structure is encroaching into the neighbor site.
Yes, this is B. This is B by 2. This is B by 2. This is 2 times B. Okay, you can approximately arrive. Okay. For that, you need a soil test to what is the size of foundations. Normally, for 1-story building, okay, 1.2 to 1.5 meter is the width of foundation. For 2-story building, 2.5 to 2 meter may be the width of foundation. For 3-story building, 2.5 to 3 meters may be the width of the foundation. This is very, very approximate. Okay, so that is B. What is your width of foundation? Is B. So B into 2 times B is the depth. B by 2 this side, B by 2 that side is the breadth. That much you have to imaginarily draw some lines like this. So your neighbor is coming here means either you have to insist your neighbor to get back, or better you go back. There are chances.
Okay, okay. Other question is scope for structural engineering in future. He is asking
What is the scope for? What is the scope for the hotel? Every day people are eating food. So a hotel person start a small hotel, restaurant, but start a small restaurant, even a coffee shop. They may become a millionaire in a year, in a 10 years or 20 years. He may start bring a star hotel brand like that. Somebody is not satisfied with a small restaurant itself. So it is a day-to-day need. Civil engineering is a day-to-day need. So people need food, people need clothes, people need groceries, people need homes, people need office, people need roads, people need pipelines, people need other infrastructures. So civil engineers and structural engineers scope is very vast, but starting shall be the trouble. Starting you have to prove that I am so and so. Most of them don't know what is riding bicycle. After a few years, we are masters in cycling. Most of them we don't know what is how to drive bikes. But when we come to college, we are wheeling the bikes. Most of us don't know how to drive a car. After a few years, we are riding in 140 km/h. Similarly, civil engineering has some lot of starting trouble because it's the oldest engineering. Lot of competition is also there. and day by day the materials are advancing. So first be a civil engineer. For a structural engineer, first requirement is being a civil engineer. You should know about all the material, all the construction activities. You start from survey to all those things. And structural engineering is a specialization. Okay. How to design a structure is a specialization. In this specialization, you have to concentrate. You study well about the code, IS codes, national building codes, and relevant codes, and know some softwares like STAAD, ETABS, AutoCAD. Then you improve your skills and knowledge, and then you practice it. Okay. So starting shall be some problem is there. For me also, a lot of struggles I come across. There are thousands of projects, thousands of victories. There are 10,000s of failures, and then there are humiliations, sadness, sacrifice. Everything is there. So all those things we have to come across. That is like. Okay, shall we move across?
Yes,
any
we can go to presentation.
Okay. Okay, so far we come across what is geotechnical, what is foundation. After the foundations, on the foundation, the very important number is columns. In this, you can see a man standing like this and holding a weight lift. Hope everyone can see this. In a strong man, a strong person, okay, can be defined if he has stronger legs, okay, than arms. You go to gym, okay, go to gym, you may make lot of exercises and arms, push-ups, pull-ups, but never your arms muscles are stronger than your thighs muscles. Okay? God designed us like that. Not only that, our everyday performance, we are using our legs to transfer the force to the gravity. Even though your arms are working, arms are carrying the load and transfer to the legs, legs transfer to the gravity. So similarly, stronger legs than arms, stronger column than beams. This is called columns should be stronger than beams. How can a column should be stronger than a beam? Okay. The first equation is AC is greater than AB. Area of cross section of column should be more than area of cross section of beam. Area. Okay. What is the size of your beam? Okay, you may arrive. There is some procedures. So area of cross section of column should be more than area of cross section of the beam. The moment of inertia I of the column should be more than moment of inertia of the beam. The stiffness EI by L, okay, EI by L of the column should be more than EI by L of the beam. Okay. So the cross section of columns should be more than beams. The moment of inertia of columns should be more than beams. The stiffness of columns should be more than beams. In the beam, so before we fix the column size, fix the beam size. In beams, beams should be like this. Okay. Cross section like this. Not like this. See, in a beam, assume there is a beam. It's a scale. Assume there is a beam. I apply the load, it bends. Smoothly bends. I turn it, same span, same cross section, but it won't bend. It won't bend. Why? Now, the moment of inertia is B is wider. D is negligible. D cube by 12. Now, B is negligible. D is more. D cube by 12. So that is why I cannot bend. But this I can bend. This, when you are going to practice as a structural engineer, You face a lot of same questions from clients or even architects. Sir, you are giving a beam size of 230 mm by 600 mm. Why not 600 by 230? Yeah, it's not possible because even a scale it is not possible. How can possible on beams? Scale is not receiving much loads other than fingers. Okay. Whereas in beams, it is having tons and tons of load. Okay, so fix the beam size first. IS 456, there is a code. Okay. In this code, there is a recommendation to how to array the beam depth. Code is very silent about beam width. However, the width of beam not less than 8 inches or 9 inches. Don't go for 6 inches. Okay. As per IS code, the minimum width of size of beam is 200 mm. Better go for 230 mm. Okay. So depth of the beam should be more than width of beam, not more than 4 times width of the beam. If by some case, if it comes more than that, you have to increase the width of the beam also. Normally, in practical conditions, before going deep into the code books, practically people keeps for 1 feet span, 1 inch is the depth. That is, the span is 10 feet, depth is 10 inches. The span is 20 feet, the depth is 20 inches. The span is 30 feet, approximately the depth is 30 inches, inclusive of slab thickness. Slab thickness 5 inches or 6 inches, inclusive of slab thickness, the beam size is arrived. Okay. This is how the column should be arrived. Okay. The moment of stiffness is nothing but I by L. If the E is constant, moment of inertia of the column should be more than moment of inertia of the beam, and the moment of inertia divided by length. The beam stiffness is nothing but I divided by L, stiffness. Okay. Normally we are scolding our loved ones in house. The chapati is very stiff. Okay. What is stiff? It is not easy to deform. Simple. Okay. So the column should not be easy to deform than beam. Beam may slightly deform. The column should not deform comparatively. Okay. Area cross section of column should be more than area cross section of beam. Moment of inertia of the column should be more than moment of inertia of beam. If a beam may bend, beam or resting on column, okay, the column should not bend before the beam bends. How a column behaves. If the columns are stronger, okay, this is when the load is applied as a compression, it's an eraser, how it buckles. Okay. When columns are stronger and beams are sleek, this is called stronger columns. The columns are sleek and beams are heavier. It will buckle. Few years ago, even now, when my times in school days, there are people affected by a particular disease called polio. Their legs are very thin. They cannot stand without help of a stick or some specialized shoes or artificial legs. Similarly, but now polio is almost eradicated all over the world, in particular in India. Similarly, if the columns are sleek, you follow clients' advice or architects' compulsion times, then your building shall be a polio attack. Almost, I'm sorry to use that word, but almost like that. Okay, the polio attack, the person cannot withstand without proper supporting system. Okay. Similarly, in columns. Already I said the moment of inertia. Okay. The moment of inertia is initial for any structural engineering members. Initially is your father. Whether you like your father or not, your father will safeguard you. Similarly, in a member, the moment of inertia is the initial. The moment of inertia is stronger, but members will not bend, deform. Okay, for different type of, let's say rectangular sections there is a moment of inertia formula. Different for circular, it is 5d for 4 by 36, like that. There are triangular columns, there are some separate moment of inertia. So the students should learn moment of inertia well, because that is the very basics for the entire civil engineering, structural engineering. Okay, we arrived at a column stronger than beams. Now, how to orientate the columns? Not only the cross section, not only the moment of inertia. The orientation also very important. This is a plan of a marriage hall, auditorium like structure, convention center like structure. This is a portico. This is a lobby. Here is a tiny hall. Food is very important when you enter into tiny hall. So in the ground floor there is a tiny hall. Okay. When you rise, here are staircases. When you come to the upper floor, these small columns are get terminated inside the tiny hall. So the span is around 50 feet, 55 feet. See the column size. The column should face. Okay, which side is the major size of the column should face the major axis. See, the column and beams are get tied like this. When the beam try to bend, it should not bend the column. By any local conditions or constraints, if you turn the column like this, that is the minor size facing the major axis. When the beam bends, the column also bends. So there is a stability question. So the column should face such a way where spans are more. Here the columns spacing is span is more here, span is less here. If suppose the columns are here also 30 feet, here also 30 feet, then you go for either square column or circular column. So the choice of the size of the columns is not only in the architect's hand but also in section engineer's hand. Okay, we have to be very strong and don't compromise on it. I lost lot of projects by not compromising my column size. Okay, because if anything happened tomorrow, section engineers shall be seemed as an accused. Okay, so don't allow your own action will bring your own fate. So be strong on it. Column size should face marking the maximum span. Okay, that side it has to face. Should not bend. If you turn like this, it will bend. So here, lot of issues. It's not easy to say in practice. People fight like anything for this. They want plastering smoothness. They want tiles to be laid properly. They want aesthetics, whatever may be. Be stubborn and strict. Even people scold you. Don't worry about that. Even our parents are scolding us. Wives is scolding us. Spouse are scolding us. We don't worry. So in this also be adamant. Don't worry. What I want. Okay. So that is why I'm insisting so many times about the column size and orientation. Next is stability. When you graduate a master's in structural engineering or you are practicing as a structural engineer, people are asking about the stability certificate. Stability certificate, how to use stability certificate? Go to the area, see the area, take photographs, drinks a cool, have a cool drinks, okay, make a handshake, and then put in a seal, get 5,000 or 50,000 or 50,000. It's not stability certificate. Okay, stability certificate is nothing but it is stable for all type of loads anticipated in a particular area. So you have to check first foremost thing is ABC. A for anchorage, B for bracing, C for continuity. A column has to anchored on the foundations. Every column should be anchored on the foundations. So one column anchored here, another column anchored here, that should be braced by beams or bracings. Okay. And there is a continuity, continuous in x-axis, continuous in y-axis, continuous in z-axis. This is the basic requirement for any stability. If it is not there, stability is questionable. Okay, don't give, you put a sign and you are, anything happened, you are in charge. 2 years ago in Chennai, a 11-story building collapsed, designed by somebody, and but stability certificate is given by somebody. The person who gave a stability certificate was also arrested and screwed for many times. The police stations and commissioner office and as well as the court, and his license was cancelled to practice. I am not apprehending you, but be careful. The ABC is very important, anchorage, bracing, continuity. Okay. That is a basic for any structure. To design a structure, you ensure ABC globally and total and locally. Okay. The entire structure has to have ABC in all axes. Then only stability is comfortably comes. If anything is missing, you have to make rigorous analysis of computer, and then you recommend. Okay. Don't blindly see, and people are putting very nice finishes and then give stability. Okay. But sexual engineer job is nothing but an orthopedician in a hospital. Okay, whatever the nice jewelry you wear, whatever the nice shirt, saree you wear, okay, whatever maybe your skin complexion, see the bones, see the flesh, and how the system of skeleton. So similarly, be careful about the stability of structure is ABC. Okay. Okay, we designed everything as per soil report. We designed ABC, followed ABC. We give the input in StatPro or any ETAP software. Software gives the output. Okay, software does not know about, software is not going to construct buildings like 3D printing. So for 3D printing is not coming to structural engineering or civil engineering. When it comes, then there will be another problem of unemployment may be there. Okay, but okay, if it is a software gives output, how to check the output? The problem so far discussed is how to give the input and how the process is. The software is giving output. How to check the output? There are very simple two tests are there. Stresses should be within limit. Deflection should be within limit. So every person have receiving stress. If you are a student, when the exams are announced, you are getting stress. Okay, you have 5 or 6 papers to write for every semester. The stress level is less. If we have 5 or 6 arrears, the stress level is more. If we have more than 10 or 15 arrears, the stress level is very high. You cannot fulfill. At one stage, you will broke. That means you fail. Okay. Similarly, for every family head, he has stresses, financial stresses. Okay. That is, the wife is giving budget. Kids are asking for school fees, his bike petrol, maintenance, apartment rent or EMI. So the father of the family or the head of the family has stress. So stress should be within limit. Beyond the stress, any member will deform or broke. So similarly, if there is a column, there is an allowable compressive stress. If it is a beam, allowable flexural stress. If it is a slab, allowable flexural stress. If it is a foundation, allowable punching stress. So the stresses will be within limit. You want to check. The IS code gives what is the stress on every columns, every beams. So allowable stresses. For example, for a column, if you are loading in a column, so load divided by area is a compressive stress. That should be less than 0.45 FCK. So similarly, in the beams, there is allowable flexural stress. For foundation, there is a punching stress, how the beam column junctions. That thickness should be sufficient. And the deflection, you are resting on a slab or you are resting on a balcony. Definitely deflect, but you don't realize the deflection. That should be there. A structure is called failed structure. It need not fall down completely. Even the deflections are noticeable and people are scared to enter into the structure. Structure is a failed structure. You enter into the car or bike, the handlebar is wobbling, the steering is wobbling. Will you drive the car? Even the car is good or bike is good. No. Similarly, in a building, the deflection should be within limit, very minimum. There are codal norms given. For this much is the span, this much is the deflection. Like that. You got to follow. There are two theories of structural design in RCC. One is called working stress method. Another is called limit state method. Working stress method is used to design water tanks. Limit state method design for all type of buildings. Why working stress is suggested for designing water tanks? Because in limit state we are allowing the material to strain as much as possible to the limited deflection or limited crack width or limited yield. So there is a chance of water may penetrate inside the sections. But in working stress, we are highly reducing the stress working on the numbers, and the balance is the reverse residual stress and not allow further deformations and not allow the structure mild cracks even. So it is uncracked sections. Working stress, that is uncracked sections. The limit state all buildings are designed. That means not we are not deliberately allowing cracks, but there is a chance of cracks. Crack width is also in another criteria, the usability. When you come for design, you know all those things. How to detail it? Okay, whatever you design it. The problem is we people know how to do designs in a StatPro or any very good software. How to detail it? We already discussed wherever the tension comes, you have to give the rods. Okay, whatever you design in a double integration method or stiffness method, masons don't want all those things. They want, sir, what is the thickness of concrete, what is the reinforcement, that's all. They don't want anything. Okay. What we expect from the government, we expect comfort, less tax, or even tax free. Okay, we don't want anything about what is internal matters in the government. Similarly, the field people want what is the thickness of reinforcement, what is the thickness of foundations, what is the reinforcement, thickness of beam, what is the reinforcement, size of column, what is the reinforcement, like that. So in this, you have to detail, while detailing it, you have to ensure whether there is a chance of tension and the rods are provided properly. In field conditions, you have to put the rods and then give the cover blocks. This is called cover blocks. It's a factory made or site made pre-casted concrete blocks that should be laid below your foundation, below your plain cement concrete. Don't use bricks, brick bats, or any other similar such materials, or 40 mm jelly. So what happens when you concrete it and then putting a pressure on the column, this all will crack. While it will crack, the moisture may go inside and corrode the entire mesh, and the corrosion starts from here and travels to up. So please don't do this. Do it properly with cover blocks and avoid the brick bats or any other foreign materials than concrete. And detailing of rebars in columns, mostly people use in columns only the outer rings. But when the spacing between the rods are more than 75 mm, you have to give some additional rings like this. Okay. In this, there is a do's and there is don'ts. There is don'ts, there is a do's. You have to give a proper cover blocks. Okay. The rods should be straightened and the spacing of stuff should be properly maintained. Okay. There is no, don't allow sway like this. This is an incorrect method, this is a correct method. Okay. Single tie may not be sufficient in most of the cases. Okay. In cover should be 1.5 inches minimum per column. People give only 1 inches, 25 mm. That is a major error mostly happening in sites. So in beams it may be 1 inches, but in columns it will be 40 mm. Okay. So give the proper cover. And in footing reinforcements, don't do lappings. Okay. Okay. Don't make laps. Put straight bars as far as possible. Put straight bars. Don't make laps. Okay. Put lap-free straight bars. And below the foundation, people put sand filling. Okay, you have to ram it properly with a compactor. And putting PCC, people put jelly, that is 40 metal aggregate, and over the water and the cement mortar. That is not a good practice. Mix the concrete either mixer machine or handmade, and then put the concrete. And for form work, okay, this fellow good very good form work, but the brick bats are used. Okay, so use proper form work around your footing. Don't go like this to the edge of the soil. Okay, put proper timber forms or any other forms. And while the footing pad is cast, you have to give the starter. The starter should have minimum thickness of 150 mm, and then the proper cover in all around. Okay. Inside this, there is a development length. Okay, this is called LDC, a small letter given LDC, development length in compression. This is called LDT, that is development length in tension. The LDC is 40 times diameter mostly. The LDT is 50 times to 60 times diameter mostly. So if we use 12 mm rod, the LDC should be 12 into 40. That much of distance should go inside as vertical. Okay. Some people use some form sign and all, some special forms. They sometimes sacrifice the thickness, the penetration. Right? They say our technology is very good. No, don't go along with that. What IS code says, if a column or a shear wall goes inside your concrete or the footing or the foundation, the LDC should be followed. Okay. And in case of columns, don't lap all rods at a single point. Okay. More than 50% lapping should not be done in a single locations. It should be staggered. Lapping should be staggered. Okay. And beam column junctions. See, in a house, we are drying the laundry, our clothes from the washing machine on hand washed clothes on a nylon rope. The nylon rope has a lot of ties and one end on nail on another nails. Okay. We are putting a bed sheet or dupatta or sari or dhoti or a pant on a wet condition on a nylon rope. What happens? The nylon rope sags. If the nail and knot is not strongly tied, what happens? The nylon rope sag and sometimes pull and totally collapsed. Similarly, the top rods should come down, the bottom rods should go up. The rod in tension should come to compression, the rod in compression to take up to tension. So lock like this. Then only it is 90% fixed. There is fixer and hinge you may study it in your design classes. Even though if you are doing like this, it is not 100% fixed, it's 90% fixed. If the column sizes are less, it's very difficult to give a development length. When the column sizes are sufficient, okay, you can give a development length. Here also, the development length is 50 to 60 times diameter. Okay. Then only most of the people ask, sir, I put top length, top development length. Is the bottom development is necessary? Yes, it is necessary. And beam column junction, it should be bent like this. Then only you can ensure proper connection. Slab mostly yield, excuse me. So any doubts about the beam column junction of the column? Yes? can ask or put in text. Ashok, shall we proceed or any
Yes,
doubts?
you can proceed. No doubt. I was in mute.
Okay. Time is also going on. Okay. So after that, we come to the end is, so in construction, in design start from slab, and construction we start from bottom. Okay. So the topmost portion is the slabs. You assume a biscuit, a Britannia 50/50, a square shape. You apply force on it. Okay. In a slow motion, it will crack. If you uniformly apply the force, it will crack like triangles. That means the load is transferring like this. You take a Britannia milk bikkies, you apply a force on it in a uniform manner, it will crack like this. This line is called yield line. Yield means you are losing. So, like this way, the load is distributed to the beams. Okay. Like a bingo, okay, there is a triangle. If you apply the load, how it yield? It is a after hexagon, it is a circle like a Mary biscuit. You apply pressure on it, how it cracks. Why you know about yield line? Because from the yield, there are formulas how the yield is happens. From the yield only, the load transfer to the beams. The slab load transfer to the beams. Okay. So the slabs are detailing like this. Don't be. It is messy. Don't be afraid about it. It's very simple. Okay. When a slab is bent like this, okay, so here is sagging, here is hogging, is going lifting up. So to avoid sagging, there is a bottom rod. To avoid hogging, there is a top rod. And here is sagging, here is hogging. Again, here is sagging, here is hogging. Here is sagging, here is hogging. Okay. So like an inverted spoon shape. Okay. In these do's and don'ts are there. People use sometimes the jelly, that is a small aggregate instead of cover blocks. Use precast 20 mm cover blocks and don't lap on the tension zones. And use chair rods. People are putting the top reinforcements without chair rods. Chair rods should be given like this. Either 10 mm or 12 mm chair rod to be used. In beam detailing, here is major bending moment, negative bending moment, positive bending moment, again negative bending moment, positive bending moment, sagging, hogging, sagging, hogging. So similarly, the beam should be detailed like this. This is the longitudinal section of a beam. When you make cut sections, okay, the beams are shown like this. This is our top reinforcement, the bottom reinforcement, and this is stirrups. The shear force is maximum at the end and the zero, almost zero in the minimum, and then again maximum at the end. So shear force is transferred by the stirrups, rings. Okay. The stirrups are closer spacing at the beam column junctions and can be economized in the middle where shear force is very negligible. And then you have to again increase the stirrups. Don't lap on the beam column junctions. Okay. You have to go at least 1/4 away from that and then lap. Don't on beam column junction you don't lap. Similarly, the bottommost portion you don't lap. You have to go in the bottom rods. You have to lap on the beam column junction. The top portion you have to don't do beam column junction lap. More steel does not guarantee more strength. People think in RCC, sometimes they, sir, your column sizes are bigger. You put more steel and reduce the column size. So number one is stress level will increase. Number two is if I put more steel, what happens? Steel will be comfortable. Concrete will not be comfortable. Concrete will crack. Concrete is a brittle material. So it is like a coffee. In coffee, decantation is steel, milk is concrete. If decantation is good and the milk is not good, you will not enjoy the coffee. Okay. So if you are more decantation, the coffee is bitter. That's for example I am saying. In mostly we are using 1% reinforcement, 99% concrete. That is the cross-sectional area. So area of steel is very, very less if you are using RCC. You should know about concrete better. In this concrete, water cement ratio is a very important criteria. For no water, concrete cannot be done. If there is more water, see, the strength will reduce. So water should be optimum. And next to that, steel, concrete, formwork. Yeah. Without proper formwork, you cannot. There is a code for formwork, IS 14687. Okay, how to make formwork? You can go to the code and then study in word. The fresh concrete almost semi-solid. Okay. In this, if you pour it, the concrete on the formwork, the very simple thing is the concrete should not leak while during compaction. Okay. Many accident happens inside because due to poor form. So when you, as a site engineer, when you go to a site, don't simply climb. First go on, check the formworks are right, okay, tighten properly. Then you climb, because anything happens, you will injured or even there is a death or possible in sites. The materials of RCC is cement, fine aggregate, coarse aggregate, water, admixture, steel, and tools. So know about cement. What is the cement date? That is very important. If there is more than 3 months, cement compression strength is reducing. In fine aggregate, coarse aggregate, there is IS code IS 383. Study it. Water in IS code 456. The first page, first table is about water. Whatever the good cement, what good concrete, steel you may use, but the water is salty, objectionable water if you use, then everything may get deteriorated. Okay. For funny things about our engineers, I am very strongly saying there is an argument with me and a site engineer. Sir, how can we expect the good water? Whenever I go to site for checking the concrete, without hesitation, I take the drum. In the drum, we are putting water. I take the water in my hand and then taste it. People may somebody hesitate, but I don't hesitate. Yes, that is very our job. Check the water by. If I am not able to consume the water, if I don't like the water, I don't allow to the concrete. There is a site engineer arguing with me. How can you expect such a good water for concrete? I said, in mixing alcohol, you are mixing mineral water. Okay. The alcohol is not good for health. Anyway, you are mixing Kinley or distillery or something. But that structure will going to withstand for several years and even centuries to use good water. Sorry for to say this because people are very lethargic about water. Admixtures are nothing but adding sugar in the coffee. More sugar also not good. Some sugar add some taste. Okay. Similarly, admixtures make some easiness in the concrete. Steel, you want to study about, there is a code about steel 500. What is 500? What is 550? Why it is 500T? What is 550T? Where to use? And formwork tools, what is vibrator, the mixer machine, the pump. So all those things, please be study all those things, and then you approach the site. Curing is very more important. Okay, you use good water, you use good cement, you use good steel, you good formwork, and if it is not properly cured, strength will not get achieved because the concrete is a chemical reaction while hardening. It's exothermic. There's a lot of heat is generated in the concrete. The concrete generates heat. Okay, and the water get evaporated. When the water get evaporated from the concrete, the further reaction will not take place. So that is why we are pouring water on the concrete to maintain the water inside the concrete. With minimum 7 days to be cured. Any concrete, maximum of 14 days enough. Moist curing, you can wrap with sacks or canvas. Membrane curing, steam curing for precast concrete. Now I come to the conclusion. So far, in structural engineering, we covered only steel, RCC, not steel sectors, and geotechnical aspects we covered. RCC is a reinforcement concrete, is conventional economical material. If you go to the steel, it is costly. Steel sectors are, that is why it is not famous in all over the world, even in India. The developed countries may use skyscrapers, they use steel sectors. Next to water, concrete is consumed. quality of rebar and the quality of concrete are both equally important. The formwork decides the output of the concrete works. So good formwork should be used. Strict supervision during concrete and cube samples. So every concrete to be tested with cubes. Strict supervision is insisted. If a RCC structure, if it is properly designed and properly constructed and properly maintained, then it gives 75 years service life by book value. Every mistake, 5 years shall be reduction. If you make 10 mistakes, 50 years.